You ever see those big factory machines, the ones where it's like spraying water or oil everywhere?
Yeah.
Kind of makes you wonder, is that just like industrial messiness? Or is it actually like essential to what's going on?
Mhm.
Especially after looking into wire EDM, it really makes you ask, is that fluid just a byproduct? Or is it fundamental to the process?
You're right. It really gets you thinking about the role of that fluid, doesn't it?
Yeah.
In wire EDM, it's not just a messy side effect, it's absolutely vital.
Oh, wow.
If you skipped it or used the wrong kind, well, let's just say you'd be in a heap of trouble. Sparks going crazy, cuts that look like they were done with a hacksaw,
Yikes.
damaged parts, a broken wire,
Yeah.
even a wrecked machine.
Oh, that's not good. So basically, we're on a mission here to understand why this cutting fluid, or dielectric fluid, is so critical in wire EDM.
You got it. It's not just for show, you know.
Yeah, yeah.
Ignore it, and you'll likely end up with a pile of scrap metal and a very unhappy EDM machine.
Okay, so what's this fluid actually doing? What makes it so important for a successful cut?
It wears a lot of hats, that's for sure.
Okay.
First off, it's a dielectric medium. Think of it as the traffic cop for the sparks, making sure they happen only where and when you want them. Keeps those electrical discharges stable, which is what actually does the cutting.
Okay.
Second, it acts as an insulator between the sparks. Prevents them from jumping where they shouldn't.
So it's keeping things in order.
Exactly. And because those sparks create so much heat, we're essentially melting metal. After all, the fluid also cools things down,
Hmm.
prevents everything from overheating.
Right.
Finally, and this is crucial, it flushes away all those tiny bits of metal that get eroded during the cutting. All that debris has to go somewhere.
So it's like a multitasking ninja, controlling the electricity, cooling everything down, and cleaning up the mess.
A pretty accurate analogy.
Okay, so that makes sense. But then you hear about all these different types of fluids, deionized water, oil, emulsions. It's a bit confusing.
Yeah, I can see how it can get overwhelming.
Does it really matter which one you use?
Oh, absolutely. It can make a world of difference.
Really?
Using the wrong fluid, or even fluid that's dirty, can really slow you down, affect the accuracy of your parts, give you a rough surface finish, and even cause problems with your machine.
Okay, so big implications. Let's talk about the different types.
Yeah.
Our sources seem to agree that for a lot of modern wire EDM, especially the low-speed kind, LSWEDM, the go-to choice is deionized water.
Right. That's the workhorse for sure, especially when you're after the highest precision.
Okay.
And there are two main reasons for that. Its dielectric strength and its ability to flush away debris.
So let's break that down. Dielectric strength, what does that even mean in terms of getting a precise cut?
Well, it means the fluid has to be a good insulator.
Okay.
It can't let any current flow between the wire and the workpiece, except when you want a spark to jump that tiny gap.
Got it.
And deionized water is excellent at this. It can handle high voltage without breaking down, which gives you that fine control over the cutting process. It's like a really effective electrical fence. The charge stays put until you decide to open the gate.
So it's like directing that energy exactly where you want it for the cut.
Exactly.
And then you said it's good at flushing away debris. Why is that so critical?
Well, when that wire is eroding the metal, all those tiny sparks create microscopic particles. If you don't get rid of them, they cause all kinds of trouble. Short circuits, interference with the next spark, a messed up surface finish.
Yeah, I can see how that would be a problem.
Deionized water is pretty thin, low viscosity, so it flows easily. You can pump it through that narrow gap with high-pressure nozzles, blasting those particles away like a tiny, powerful jet stream.
So it's like a built-in cleaning system working for you.
Yeah.
Cool. Now, our sources also mention oil-based fluids.
Right.
Where do those fit in?
Not as common overall, but they have their place.
Okay.
If you need the absolute best surface finish, like a mirror finish on certain materials, oil-based fluids can help with that.
Interesting. So a trade-off then.
You could say that. Maybe not the fastest cutting or the best debris removal, but if that super smooth finish is what you need, oil might be the way to go.
Got it. And what about those mixtures? The oil and water emulsions. Our sources say they're pretty common in high-speed HSWADM and middle-speed MSWADM machines.
Right, emulsions.
What's the advantage there?
Well, with those machines, it's less about the super high precision of low speed and more about getting the job done quickly and efficiently. Emulsions give you a good balance.
Okay.
Some of the cooling from the water, some lubrication from the oil, which can help with faster cutting. They do some flushing too, though maybe not as well as pure deionized water.
So it's about finding that balance of properties.
Exactly, finding what suits your application and the machine you're using.
Right. And speaking of finding the right thing, you mentioned dirty fluid.
Oh,
It's not just about what fluid you use, but keeping it in good shape.
absolutely.
So how often should you replace this cutting fluid? I imagine that can be a bit of a pain and an expense.
It's something to think about, for sure. You might think you're saving money by stretching it out, but in the long run, it can really backfire on you. Slower cutting, less accuracy, worse surface finish, broken wires, even rust on your machine or parts.
Not worth it. So is there a rule of thumb, like change it every month or after so many hours?
It's not quite that simple. It really depends on a few things.
Like what
Yeah.
should you be paying attention to?
How much are you actually cutting? How long are you running the machine? How good is your filtration system? A better filter will mean less frequent changes.
Okay, yeah, that makes sense.
And then the type of fluid, of course. What material are you cutting? Some are tougher on the fluid than others. And of course, how good do your finished parts need to be? The higher the quality, the more you need to be on top of your fluid maintenance.
So it's kind of a judgment call based on all those factors, but how do you really know when the fluid's had it?
Well, think of your machine's fluid system like the circulatory system in a car. You've got filters to clean it, but eventually the fluid itself gets worn out or too contaminated.
Mm.
In wire EDM, the fluid is constantly picking up tiny metal bits and byproducts from the electrical discharges. Your machine probably has paper filters to catch the solid stuff.
Okay.
And if you're using deionized water, you'll have deionizing resin that removes the conductive ions, keeps the fluid's dielectric strength high.
Right, so the filters get the physical stuff and the resin keeps the water electrically pure.
That's a good way to put it.
Yeah.
But those things have limits, of course.
Right.
Filters get clogged, resin gets saturated,
Okay.
and some materials, like aluminum, make the fluid more conductive really fast. The filters and resin just can't keep up.
So what are the telltale signs? How do you know your fluid needs attention?
Well, if it's visibly dirty, or if the conductivity is too high, if you're using DI water, that's a bad sign.
Makes sense.
You'll start to see all those problems we talked about. Unstable sparking, slower cutting, bad surface finish, rust, broken wires. You need to keep an eye on things to avoid that.
Right. Our source helpfully included a little table of maintenance tasks. First up is replacing those paper filter cartridges.
Yeah, the workhorses.
How often do you usually do that?
It really depends on how much you're cutting, how fast they get clogged up. One good indicator is the pressure in your system. If you notice it's starting to climb, that usually means the filter's getting full, restricting the flow.
Okay.
The main thing is to keep the fluid clean, right?
Makes sense.
Get those solid particles out.
Next up is regenerating or replacing the deionizing resin.
Right.
That's all about monitoring the conductivity, right?
Yeah, your machine probably has sensors for that, keeping a constant eye on it. When the conductivity gets too high, it means the resin's not doing its job anymore. Time to either regenerate it, if you can, or replace it entirely with a fresh batch.
So essentially you're refreshing the resin to maintain that crucial dielectric strength we talked about earlier.
Exactly. Keep those sparks under control.
Okay. What about checking and cleaning the conductivity sensor itself? How often should you do that?
Pretty regularly, Every few filter changes, maybe. You want to make sure it's clean and working properly. A dirty sensor can give you false readings, which could lead to problems even if your fluid is fine.
Right, you don't want to be misled by bad data. And then there's cleaning the actual fluid tank.
Yeah.
Sounds like a fun job.
Well, it's not the most glamorous task, but it's important.
Yeah.
Over time, gunk builds up in the tank, and you don't want that getting back into the system and causing problems. Do it every now and then, maybe when you're doing a full fluid change.
Got it. And finally, the big one. Replacing the entire batch of fluid. When do you know it's time for that?
That's when the fluid is just too far gone. The filters and deionizing system can't keep up, too much contamination, or the fluid itself is broken down chemically.
Right.
Or maybe you've tried everything else and the cutting just isn't good.
Okay.
It's time for a fresh start.
Makes sense. So the takeaway seems to be to follow the manufacturer's guidelines, of course, but also to be proactive.
Yeah, absolutely.
Keep an eye on those conductivity readings if you're using DI water. Visually inspect the fluid regularly, keep track of those filter changes, and see how your cuts are looking.
Exactly. Be proactive.
Good fluid maintenance sounds like the key to avoiding a lot of hassle and expense down the line.
It really is. It's an investment in keeping your machine running smoothly and producing good work.
Absolutely. Now, shifting gears a bit, let's talk about the wire itself, another crucial part of wire EDM.
Right.
And this is where things get really interesting. Low-speed WEDM, according to our sources, uses this relatively pricey wire, usually copper, brass, or something coated, and it's tossed after just one pass through the workpiece.
Hmm.
Seems pretty wasteful at first glance.
I can see why you think that.
Why this single-use approach?
It all boils down to precision. Low-speed WEDM is all about achieving incredible accuracy, like down to the micron.
Okay.
And to get that, you need absolute consistency in your cutting tool.
So why not reuse the wire? Why not save some money?
Well, think about it. During the cutting process, that wire is subjected to intense heat, it's under tension, and it's constantly being eroded by the sparks. Even the tiniest change, a little bend, a slight change in diameter, a shift in the material properties, would introduce unacceptable errors in the next cut.
So it's all about maintaining that pristine condition, even down to the smallest detail.
Exactly. Every cut needs a fresh start.
And the machines are designed with this in mind, right?
Absolutely. LSWBM machines have this continuous feed system.
Okay.
The wire comes off a supply spool, goes through the cutting zone at a controlled speed, usually very slow, less than 0.2 millimeters per second. Then it's wound onto a take-up spool and discarded. One-way trip for the wire.
Interesting.
And they often use copper or brass for the wire because they're excellent conductors of electricity.
Mm.
You need that for those controlled sparks, especially at those slow speeds. Copper, for example, has a conductivity of around 5.96 times 10 to the 7th Siemens per meter.
Wow, that's a lot of conductivity. So to sum up, reusing the wire in LSWDM is a no-go because of, what, 4 main reasons?
Yeah, you got it. Precision is paramount. Any change in the wire is unacceptable. Second, the heat and tension can change the wire's properties, even slightly. Third, wear and tear from the sparking changes the wire's surface. And finally, the machines are designed for single-use wire. Trying to rewind and retension it would be a nightmare.
Right, so it's all about that pristine wire.
Exactly.
So you're essentially trading off the potential savings of reusing the wire for the guaranteed precision and surface finish of a brand new piece.
Right.
Makes sense. Now here's the curveball. High-speed and middle-speed WEDM, they can reuse their wire multiple times.
Yeah, that's right.
How do they get away with that? It seems like it goes against everything we just talked about.
The key is the type of wire they use and the overall focus of the process. High-speed and middle-speed machines mostly use molybdenum wire.
Molybdenum, okay. What's so special about that?
Well, it's incredibly strong and has a very high melting point.
Okay, so it's a tougher wire to begin with. How does that help it handle being reused?
Its high tensile strength means it can withstand the stress of the back-and-forth motion in those machines. High-speed WEDM, for instance, can have wire speeds of 8 to 10 meters per second, constantly going back and forth. A copper or brass wire would just snap under that kind of stress.
Right, would never hold up.
Exactly. And the high melting point helps it resist the damage from all those sparks.
So it's built for punishment, but surely even molybdenum wears down eventually, right?
Of course, it does wear down.
Okay.
Its surface changes, and eventually it needs to be replaced.
Okay.
But the key is that HS WEDM and often MS WEDM aren't after that ultra-high precision. Their accuracy requirements are a bit looser, usually around plus or minus 0.015 millimeters or more.
Yeah.
That gives them some wiggle room.
Ah, so the wear and tear is within acceptable limits.
Exactly.
And the big advantage, I'm guessing, is that you save a lot of money on wire.
You got it. Reusing that molybdenum wire really cuts down on costs, which is a major focus for those processes.
Right.
Speed and cost effectiveness. And while MS WEDM might use multiple passes sometimes for a better finish, they still rely on that reusable molybdenum for most of the work.
So it comes down to what you need, right? If you need the ultimate precision, LSWEDM and its single-use wire is the way to go.
Right.
But if speed and cost are more important, molybdenum is the workhorse you need.
Precisely.
It's fascinating how different needs lead to such different solutions.
It really is.
You know, it's amazing to see how much thought goes into something like cutting fluid and wire.
Yeah.
These seemingly simple things are actually quite complex.
It's a reminder that there's a lot of hidden complexity in modern manufacturing.
Absolutely. So for our listeners, here's the rundown. Cutting fluid in wire EDM is essential. It controls the sparks, cools everything down, and gets rid of all those tiny metal bits.
Right.
For high-precision, low-speed work, deionized water is the top choice. Faster, high-speed, and middle-speed applications often use emulsions. And keeping that fluid clean through regular maintenance is key to keeping your machine happy and getting good results.
Absolutely.
As for the wire, it's all about balancing precision and cost.
Yeah.
Low-speed WDM needs that fresh, single-use copper or brass wire for ultimate accuracy. High-speed and middle speed can use and reuse that tough molybdenum wire, saving money and speeding things up.
It's all about choosing the right tool for the job.
Absolutely.
It's interesting, isn't it?
Yeah.
How the specific demands of different processes lead to these specialized and sometimes seemingly strange solutions.
Yeah, like that disposable wire. Who would have thought?
It makes you think about all the design choices and trade-offs that go into these complex manufacturing systems. Really fascinating when you stop and think about
It really is. It makes you appreciate the ingenuity behind it all.
it.